Hello friends, uh, good morning, good afternoon and good evening to everyone watching this video. So today we are going to learn about sets. We have already made a video on sets. So this is the part 2 of that. This is the part 2 of sets. If you haven't watched the first part, then you can go in our channel and watch it and then come back here. So in today's video, we're going to learn a few topics, a few remaining topics. Then we're going to solve questions. I have prepared some easy questions and some questions of J also. So we'll be solving that. But before that, let's complete our remaining topics. So in this video, we're going to learn about subsets, proper subsets, supersets, power sets, universal set and complement. I have already talked about complements in my last video, but we are just going to go through it once again. So yeah, these are the topics we are going to learn today. So let's continue with our video. Alright, so our first topics is subsets. So now a set A is a subset of set B if every element of A is also an element of B. So the notation of this subsets is this. This is used to represent subsets. Now what I've just talked about, we'll take up an example for this. So if we have a set A and a set B, now we can see that set A has 2 elements 1 and 2 and set B has 4 elements 1, 2, 3 and 4. Now we can say that set A is an subset of set B because every element of A is also present in B. Now if we take another example of C, set C and set D, then set C has example values 1, 7 and also 1, 7. Now we can write A and B. A is a subset of B, but here B is not a subset of A. B is not a subset of A because A contains 1 and 2, B contains 1 and 2, 1, 2 and 3, 4. So A can be considered a subset of B because every element of A is present in B, but not every element of B is present in A. So in this case, it's only A is a subset of B, not B is a subset of A. But in this case, here where both C and D have same elements, then we can write it as C is a subset of D and D is a subset of C because both have the same elements. So the order doesn't matter here, but here A is a subset and B is a superset, which we are going to learn further in our video. But for now, we just need to know that B is not a subset of A. So this was about subsets. Now there are some important points about subsets, that every set is a subset of itself. Now what? Now we consider here that A is a subset of B, but B is also a subset of itself because B contains all the values present in itself. For example, now C and D are basically equal, so it doesn't matter if I name this also C. So hence C is a subset of C. So this proves that every set is a subset of itself. Now the second important point is about phi. So the empty set, which is known as phi, is a subset of every set. Now we'll move on to our next topic, which is about proper subsets. Now proper subsets aren't a different topic, it's basically a subtopic of subsets. So the definition of proper subsets, the notation for proper subsets is this. So right here A had the same values, so we'll not take the values again because we know that A is a subset of B, but here we can also say that A is a proper subset of B because it is not equal to B. But in case of C and D, C is not a proper subset of D, and same goes for D, that it's not a proper subset of C, because these are same, they had the same elements, hence they were equal. So these were proper subsets. So basically proper subsets are subsets without same elements. Now moving on, our next topic is supersets. So as we have taken the example of A and B, let's take it again. I'm just going to write 3 here, 1 2 3. Now we know that A is a subset of B, but we can also say that we know that A is a subset of B. Now the definition of supersets are, if A is a subset of B, then B is a superset of A. So we can write it as this is the notation. So we can say that A is a subset of B, hence B is a superset of A. So these are basically vice versa. So if A is a subset, then B must be a superset. An example of C and D which had both the same elements, then both are supersets and both are subsets of each other. We can write any way, that doesn't matter. So yeah, this was about supersets. Now moving on to our next topic. Power sets. So the power set of set A is the set of all possible subsets of A. So the notation for it is power set A. Alright. So now taking the same example of A and B, A with with elements 1 and 2 and B with elements 1, 2 and 3. We don't need B for this example, but we'll just keep it here. So now for A, if we talk about power set of A, then what is the answer for this? So power set of A contains all the possible subsets of A. So what is that? So now example, if A has values 1 and 2, then what could be the possible subsets of A? Now there could, let's take it. Now there could be a subset with nothing, empty subset, which is known as phi. So yeah, that is also a possibility. Then there could be a set with only 1 present in it, a set with only 2 present in it, and a subset with both 1 and 2, which is not be a proper set, but yeah, proper subset, but yeah, it's a subset. We need only subset. So these are the total possible subsets for A. Then these possible subsets are known as power set of A. Now the power set of A contains 4 elements, phi, 1, 2 and 1, 2. So these are the elements of power set of A. Now to calculate the total possible subsets of A, there's a formula. We can write it as P of A is equal to 2 to the power of n. Now n here represents the number of elements present in a set. So if example A had values, now take example of B. So if B has 1, 2 and 3, so it has 3 values. So power set of B would basically equal 2 to the power 3, which is equal to 8. So this is how we can calculate the number of the elements present in power set. So this is a great formula we need to remember, because we are going to use it in our future questions. So yeah, just remember this, that power set of any set is equal to 2 to the power n, where n represents the number of elements present in that particular set. Alright, so we have taken an example here also. So now moving on. Alright, so our next topic is universal set, which is represented as U. So universal set is the set that contains all elements under consideration for a particular problem. So it's basically used for questions. And example, if we take U with values from 1 all the way to values 9. So this is the universal set. So now if we create a subset, a set A and a set B, then all the values present in these set must be from these values, inside these values. It cannot go like A cannot have value 10, 11, 12 or values in like 0 because it is not present in universal set. So basically universal set is power set of every set present in that particular problem. So we can write as A is a subset of U, B is also a subset of U, and U is the superset of A and B. So this is the use of universal set. It is used to define or basically limit the number of values in a particular problem so that a set contains only values ranging from like example 1 and 9. So this is the use of universal set. Now if we take an example, then for example, if we are studying natural numbers less than 10, so we have a universal set 1 to 9. Now for the particular question there is a different subset A with values 1, 3, 7. So it is allowed because it is present in this universal set. But now if we take a different set which has values 1, 8 and 13. So this is not present because this is not allowed because it's not present in the universal set. So this is an example of universal set. Alright, now moving on, complement of a set. It is denoted as, its notation is A apostrophe. This is known as complement A. So the complement of a set written as this is the set of all elements in the universal set that are not in A. Now taking the same example as before, that U contains values from 1 all the way to 9 and A contains 1 and 2. Now what is A complement? So basically A complement is universal set without the values of A. So here value of A complement would be values from 3 all the way to 9. So 1 and 2 was present in A, hence it is not present in universal set. A complement. There's also a formula to calculate A complement, which is a very basic formula, which is that A complement is basically X belongs to, X is a variable number of like example here sets, element, X is an example variable element, X belongs to U, but X does not belongs to A. So by using this formula we can calculate the number of elements present in A and which are the elements present in A. So if we take example B, then what would be B complement? It would be it would be from 4 to 9. So this is B complement and this is the formula to calculate a complement of a set. Also is another point I have to tell. We just remove this part. That now set, we know that A complement had the values from 3 to 9 with respect to the universal set. But what if I write it like this? Complement of A complement. What would this give us? So this basically will be this. Hence we can say that A complement of A complement is basically A. Now the logic behind this is that A complements contains values of universal set that is not present in A, but if we take complement again, then it will remove the values present in A complement, leaving us values 1 and 2, which are basically the values of A. So hence this is a important relationship we need to remember. And this can go on. If example I write it like this, then it's basically again A complement, and if we do it once again, then it's again A. So yeah, even number of complements on A is equal to A, and odd number of complements on A is equal to A complement. Alright, this was an important relationship. Now we'll go on to solve some questions I have prepared. We'll start with two basic questions, maybe three basic questions, then we'll solve one question of JE. Now the first question here is A has elements 1, 2 and 3. Now we have to find all subsets of A. So all subsets of A, starting with, let's calculate the number of subsets possible, then we'll find out total subsets, like all the subsets. So we know the formula for calculating the number of subsets present is basically 2 to the power n, where n represents the number of elements present in a set. So here it's 2 to the power 3 because A contains 3 elements, hence there are total 8 subsets. Now what are these 8 subsets? We have 5, then we'll 1, then we have 2, phi is also a subset as I've already talked about. Then there's a subset which with might have only value 1, then there's a subset with only value 2, 3, then we'll move on to two elements, like there could be a subset with values 1, 2, a subset with values 2 and 3, and 1 and 3. And there could also be there's also a subset with both with all the values 1, 2 and 3, as we have talked about that subsets can have the same values as the proper set, as the superset. So these are the total number of subsets: 5, 1, 2, 3, 1, 2, 2, 3, 1, 3 and 1, 2, 3. So now we just need to verify that if it's correct or not. So let's see if it's 8 or not. There's 1, 2, 3, 4, 5, 6, 7 and 8. So yeah, these are 8 subsets. Now for our next question, before that I need to say something, that instead of writing all the elements like this for a question, if we need only the number of elements in A, then we can write it as this. This tells us the number of elements of A without telling us what are the elements, because in some questions we don't require the elements, we just need the number of elements present. So yeah, this is the notation for it, that n of A with the number of elements in A is equal to 2. So same goes in this question, that number of elements in A is equal to 4. Then we have to find P of A, power set of A. Now using the same formula we used for the last question, we can write it as power set of A is equal to the power of n, where n is the number of elements in a set. So here n is equal to 4, hence P of A is equal to 2 to the power of 4, which is equal to 16. Hence we can say power set A contains 16. Number of elements in power set A are 16. So these were some basic questions. Now moving on to a JEE level question. So this is the JEE level question. It's a question of JEE mains. So the question here says, in a college of 500 students, 260 take maths, 210 take physics, 180 take chemistry. Exactly 120 take both maths and physics, 90 take both maths and chemistry, and 70 take both physics and chemistry. If 30 take all three, how many students take none of these three subjects? So for the solution of this question, so solving this question, now we can solve it through Venn diagram also, but we are going to solve it through inclusion exclusion. Now what is inclusion exclusion? Actually there's a formula for inclusion exclusion. Now before that, let's write it in the form of sets. So for example, in a college of 500 students, so there are total 500 students. So we know that universal set n of u, number of elements in universal set, is 500, because every student is considered in this 500. So yeah, universal set is 500. The elements in universal sets are 500. Now I'll just write the number of elements in the number of students in both in all the subjects. So for maths, the number of students are 260. Then the number of students for physics 210, and the number of students in chemistry is 180. Alright, these are the single sets. Now I'll just write it. I'll explain what it is because you wouldn't understand it right now because I haven't talked about it yet. But I'll just write it right now. Now I just wrote all the information given in form of sets. So we'll move on. We don't need the question right now. So yeah, moving on. Now before solving the question, there's a formula I need to tell you about. It's a formula of inclusion exclusion. So it's written as number of elements in. Now what is this? This is basically union of M, which is maths, union of set maths, union of set P, and union of set C together combined. Now if we look it at from the perspective of Venn diagrams, then it is basically like this, a Venn diagram of three sets. So this whole part is this. Alright, we'll just keep the Venn diagram for example. So now the formula says that this is equal to alright. So this is the formula we need to remember, that the number of elements in M union P union C, union of all, the elements present in all these Venn diagrams is equal to the number of elements in set M, P, and C. So representing this using Venn diagrams is, which is what is set M. Set M is basically this circle, and what is set P? It's this circle, and for set C, this is this circle. Now if we talk about M intersection P, alright, now here the section I've marked is P intersection C, and this section right here is M intersection P, and this is M intersection C. What about this M intersection P intersection C? So the part common in both in all the sets, the area I have darkened, is this M intersection P intersection C, which is present in the number of elements present in all the three. Alright, so this is the formula we need to use for this question. So now it's basically value putting question. So let's see. Now taking the values, so we need to find how many students take none of three subjects. So first we'll calculate the students which have taken any of these subjects, no matter if they have taken 1, 2 or 3. we'll just calculate the number of students which have taken it, which have taken any one. So yeah, using this formula, this tells us if this is basically how many students have taken any one. So now just solving it, we know all the values here. We know that number of elements in M plus number of elements in P plus C, then minus M intersection P, which is 120, then minus 90, minus 70, and plus 30. So this gives us the value 400 after addition and subtraction. So now we know that number of students taking at least one of these subjects are 400. But now we need to find out number of students which have not taken any of these. So we'll just basically subtract it from the universal set. So the number of elements in universal set are 500, and the answer we require is 500 minus the number of students which have taken any one subject. So at least any one subject. So this is the answer. Hence our answer is 100 if we solve it. So yeah, after solving this question, the final answer is 100. So we have just solved a JEE mains question. So yeah, this is an inclusion and exclusion type question which requires this formula to be solved. So yeah, this was it for today. We have learned some more topics like subsets, supersets, power sets, and all that. Then we have solved few questions, basic level questions, and then we have solved a JEE level question. So yeah, this was the summary, and that's it for today, guys. Thank you for watching.